Ever wondered how electric vehicles keep their batteries from overheating? Managing heat is critical for performance, safety, and battery life, and that's exactly what thermal management is all about. Let's decode the science behind battery and EV thermal systems. Welcome to this lesson on battery chemistry and operation. In this lesson, we'll explore the basic chemistry of batteries, focusing on how they work, and then we'll take a look at the chemistry of lithium-ion batteries. So, first we have electrochemical cells. These are devices that convert chemical energy into electrical energy through chemical reactions. Each cell is made up of two electrodes, the anode and the cathode, along with an electrolyte. When the cell is in use, a chemical reaction occurs, releasing energy that generates a flow of electrons. So let's break down the role of these components. The anode is the negative electrode where oxidation happens. Here, electrons are released and flow into the external circuit. The anode is typically made from a material that easily gives up electrons. On the other hand, we have the cathode, which is the positive electrode. This is where reduction takes place. The cathode receives the electrons flowing from the anode through the external circuit. It's made up of a material that can accept those electrons during the chemical reaction. Next, we have the electrolyte. Think of this as the medium that allows ions to move between the anode and the cathode. It can be a liquid, a gel, or solid and is essential for maintaining the flow of charge. While electrons travel through the external circuit, positively charged ions move through the electrolytes to keep the charged balance. Finally, let's talk about how electrons flow. So when you connect the battery to a device, electrons flow from the anode through the external circuit to the cathode, generating electrical current. At the same time, positive charged ions travel through the electrolyte from the anode to the cathode. This movement completes the circuit and allows the chemical reaction to continue, sustaining the flow of electricity. The animation here shows the flow of electrons when the cell is being discharged or charged, and where the electrons reside when the battery is full or dead. So now, next up we have is the essentials of the lithium-ion batteries, which power everything from electric vehicles to our everyday devices. Lithium-ion batteries rely on the chemistry that lets them efficiently store and release energy. The anode, where lithium ions are held during charging, is typically made of graphite, a material that's great at capturing these ions. Over on the cathode side, we often find materials like lithium cobalt oxide or lithium iron phosphate. These specific compounds are carefully chosen because they play a big role in the battery's capacity and stability, which are very crucial for its performance. Between the anode and the cathode lies the electrolyte, a lithium salt dissolved in a solvent. This solution allows lithium ions to move smoothly back and forth between the two electrodes. During charging, lithium ions travel from the cathode to the anode, where they are stored. When you use the battery, the ions flow back from the cathode, releasing energy that powers your device. This continuous cycle of movement is what makes lithium ion batteries so dependable, and thus they are the most common batteries in use. If you found this useful and want to learn more about how EVs, batteries, and energy storage systems manage heat, check out the full course in the description. Don't forget to subscribe for more insights into EV thermal management, battery tech, and cooling strategies.